Hello everyone, welcome to another Teach to Code with Professor V, Python edition. So today we're going to go ahead and open up our Jupyter Notebook. So go ahead and find your Jupyter Notebook either in your apps, wherever you have them. For me, I like to use the command prompt for whatever reason, just get used to it, that's my way. So I'm going to go ahead and let my command prompt here open. Go ahead and zoom in a little bit. So if you're also going to use your command line here, your Anaconda PowerShell, you're going to just type in Jupyter Notebook. Oops, Notebook. Alright, so that's going to go ahead and open for me in Firefox. That's my default browser. If you ever get trouble that it doesn't open up, you could paste these URLs in there and it'll run the server in there for you. So I don't remember what notebook I was using last time. I helped a couple of students with Python, so I'm just going to go ahead and start a new one, Python 3. Alright, so that's getting opened up. So I'm going to call this, I don't remember what chapter this one is. It's chapter 3, so I'm just going to call it chapter 3. Okay. So this one's going to be all about variables. So the thing about variables is we use variables to store something, right? It stores a value. Now we could store all kinds of different data types. How come it's not giving me a scroll bar? Anyways, so, we could store integers, which are just whole numbers, whether they're negative or not. We can also use Boolean, gosh, I know I'm saying it wrong, but it's either true or false, right? So we use the equals to assign something to a variable. We use the equals to do a logical comparison. So what that means is, so for here, right, they assign a is equal to 2, they type a, it prints out the 2. Now they do another one that says, is a equal to 2? Well, that's true, right, because they just assigned it. So you could think of the variable as a place to store a number, right, an integer, a whole number, a float, a decimal, a boolean. I know I'm saying it wrong, but me and my friend used to joke about it. We used to call it boolean, but gosh, when the name comes to me, I don't know why. You ever get that where you can't remember the sound of something? But anyway, so constant is equal to 4. If you wanted it to be a float, you could do like 4.2. You could also just have it as a string. My two rules here is a list of strings, and then squares is equal to 4. So these are all valid names is what they are. Mostly, for the most part, we use underscores when we're doing Python. The capital letters are usually a little bit something else. Capital letters, I think, are for more like global variables, if I remember correctly. I might be a little bit off there. And then we can do different mathematical equations and stuff, right? So this one would actually be a good one to practice. This is a very small little chapter. So let's go ahead and get into our notebook and let's just try some stuff. So we could say A is equal to 3, B is equal to 4, and then we could do A plus B. Let's go ahead and run that, see what it does. So we get 6, right? So we could change this to maybe like -9, so it knows how to add and subtract negative integers and stuff. We could also do -9 plus 2, so you could have expressions in here. So -4, because -9 plus 2 would be -7, plus 3 more would be -6, -5, -4. So, you could play around with all these variables and do a lot of fun stuff. You could change this to minus real quick, right? 10. So if you think about it, -2 plus 2 is going to be what? -7. And then 3 minus -7 turns into 3 plus 7, which is actually 10. So pretty cool stuff that you could do all this stuff. So other than just numbers, I guess I'll just start a new cell. We could also do like maybe our name. Single quotes are the same as double quotes within Python. As far as I know, if somebody knows otherwise, please leave it in the comments and let me know that I am wrong. When working with Python, I know in other languages the single quotes are chars and the double quotes are strings. So, alright, so name is Professor V, and then I could just type in name here. So Professor V. If I wanted to print something else out, I would start with the print statement here out of my parentheses, and then go your name is. And then what we do here is we do concatenation, and then we can just print the variable out. So now if I wanted to do this with the number situation, well, let's just go ahead and do it here. Let's say C is equal to 44. Sounds like a good number. If I wanted to do this now, your number is... Well, I can't just do plus C's, so let me go ahead and run it to make the mistake. So type error. You can only concatenate string, not integer, to string. So it doesn't allow this integer to string. So this is a string here. This is an integer. So the way that we go around that, it's called parsing. So str stands for string. And if I parse it, what I'm telling Python is turn this into a string while you're printing it. So now if I run it, your number is 44. So cool way to do it. There's we could also just do it in one line over here too. So we could say something like C is equal to str C. So we're just kind of putting the variable within its own method and making it a string. So this one makes it an integer of 44. This one turns it into a string so we could print. Other than that, we could also check, like this one was doing, right? Is C equal to 44? Is C less than 45? 43, I don't know. Let's just say 5. Is C greater than 5? And then, is C not equal to 5? So I'll just do a couple of different things. Oh no, it's mad. Oh, I think it's because now I turned it into string, so we can check string and integer. So let me go ahead and move this line of code, sorry. Alright, let's rerun this. Oh, well now it's giving me heck about the print statement, so let me put the string down there. I guess I could have just erased the print. Oh, it's not telling me any of the information. Do I really need a print? I shouldn't have to. Let's see. Let me erase this and just see. So true it says. So it's only going to one of the statements, unfortunately. So if I wanted to check all these instances, I would have to use a print statement, but let's just erase it. So now it'll check is C less than 5. Well, it shouldn't be less than 5, right? Maybe it's checking the last one only. Let me go ahead and cut these out. Let's just do one at a time then. So false, right? Is C greater than 5? True, right? 44 is greater than 5. Is C not equal to 5? Oops. So anytime we do the exclamation point, we're basically saying not equal is what the exclamation means. Exclamation point will be not. So that is true, right? We'll get a false if we change it to 44 though, right? Because C is 44, right? So to say that it's not equal gives you a false, if that makes any sense. What else can we do? We could just do the equals now. We should get a true there, right? Now if we do change the number around, we will get false because now they're not equal to each other. So Boolean is a good way to check for true or false values, either 0 or 1. What else do we have? So there's a lot of how you should write the variables. If we want to do this problem, we can do it. We could copy and paste it, but you know, let's do our own equation. For me, I think that's a little bit tricky. So if you guys remember, y is equal to mx plus b, right? So let's go ahead and do this. Let's say slope is equal to 1. Let's say x is equal to 2. I don't know. B is equal to 0. Let's say it crosses the y at 0. So now we would say y is equal to m times x plus b. And then we would just call y here at the bottom. So 2. So if we think about this, the multiplication is going to happen first, so it does follow order of operations. So 1 times 2 is 2, plus 0 is 2. So you could very easily program linear equations within this, right? Simply change where you cross the y-intercept, or where you cross the y-axis with the y-intercept, rather. So now 2 times 1 is 2, minus 3 is negative 1. So, you know, really easy to do some linear algebra with on these. I mean, it's really easy to do all these different functions and beautiful things that we have, physics and whatnot. Alright, so other than variables, let's go a little bit more. So we have the strings, so word is equal to solution, another word is equal to another solution, third word is equal to third solution. So all words are equal to these concatenated. Did they add spaces in them? I should have printed them out all kind of close together. Oh yeah, it did. So yeah, because they didn't input spaces on their variables, they ended up with like things touching, right? So, oh well, I feel like they did this a little bit harder than it should be. So, you know, if you wanted to do this one, for instance, so let's say word 1, and I think it's supposed to be underscore 1. I don't know the convention, I always forget. Let's say this is, I don't know, this is. So if we leave it without the space here and we do word 2, and let's just say that is, I don't know, I'm just kind of coming up with silly stuff. And now we say word 3 is equal to word 1 plus word 2. We're going to get what happened with them, so if I hit run, oh, well, I got to call word 3 now. Oopsies, there we go. So that is that, this is that is. So if I want a space, I mean, I could just simply add the space within the the variable. But it is good to know that you can concatenate a space as well. So, you know, I'm not saying that they're wrong, I'm just, you know, it's kind of why I like programming. There's a lot of different solutions to something. So now if I add the space here with that space, it's going to double space, right? I'll have 2 spaces instead of 1. Let's see what else they have for us. So string comparison. So string comparisons are good. So we could also say something like word 1 equal word 2. So is word 1 equal to word 2? False, right? Now let's go ahead and change that to not equal to each other, and this should be true because they are not the same word, right? They're not the same string. So we could do word comparisons, which is good. When I went to school, we did like a pizza ordering app, and we had to do a lot of these comparisons to check if the user typed in pepperoni or whatnot. Okay, so other than that, it's pretty straightforward, I feel. You know, variables are to store the value. We could store strings, and then finally we get to the print statement. So, you know, the print statement really is the bread and butter of programming. You know, if you're not printing stuff out to the user, you know, what's your application doing, right? When you guys look at Facebook, things are printed out, right? When we look at Instagram, things are printed out. There's a lot of information going out to us. So we might even be able to knock out this whole chapter right away. See if there's maybe some, oh yeah, there are review questions. So name is equal to Gabby, print your name is, print name. So, oh, here they say print Gabby. Well, you wouldn't want to do it as print Gabby because it's assigned to the word name, right? Now, if you print Gabby out, oh look, they have the correction. You would need the hey gosh, the quotations. So, you know, as far as my example of Professor V up here, I couldn't just say Professor V, right? Because that's not a variable, right? It's not the variable. So we can't ever just call the string. Where the string is it's stored within the variable, right? So it doesn't like that. So I could definitely add quotes to this, but then I'm using a variable kind of for nothing, yeah. So your name is Professor V, but this is never getting used because look, if I erase it now, man, it's still going to print it out, right? And it's even redundant to concatenate these because, you know, I could just stick Professor V literally in one line of code, if that makes sense to you guys. So, you know, there's a lot to this stuff, but it's very simplistic stuff. Now we could also print out the arithmetic like we were practicing earlier, 1 plus 2. But there is a difference, so I like that example actually. So if you're hitting print and then you're doing 1 plus 2 without quotes, you're going to go ahead and get 3. Now if you put them within quotes, it turns it into a string. So essentially it's just going to print out 1 plus 2. And you could even say equals. And of course, I mean, I'm hoping you know it equals 3, but if you don't, right, we can just say 1 plus 2. And since it's not a string, right, I do... Oh, see, I don't know if this is going to work. I might be doing some silly stuff. Let's give it a shot. I might just print out 1 plus 2 again now that I'm looking at it. No, I did 3. So before it concatenates, it does the value within it. So if I didn't have the string, it's going to say you can't concatenate an int to a non-integer. Alright. Oh yeah, so look, name, Gabby, age, 2.7. 2 plus 7. So I guess you don't always have to use concatenation within Python. Concatenation is just something that I've used throughout my time. So let's see the summary. So addition, the arcsign, the logarithmics, all that good stuff. Let's see if we could do a couple of review questions. There's a couple of minutes. So how would you program 2 plus 1/2, right? So if you think about that one, right, 2 plus 1 divided by 2. Literally, 2 plus 1/2. 2.5. So that's the only value I could give you, right? 4 times 2 plus 2 fourths. So 4 plus 2 times 2 divided by 4. So what this should do is it should do 2 divided by 4, which is 0.5. The 0.5 times the 2 will be 1. We should get 5 if I'm not mistaken. So it will do order of operations, you guys, you know. Which I guess it's actually going to multiply first, right? Left to right. So 2 times 4 will be 2. I mean, 2 times 2 will be 4. 4 divided by 4 is 1. 1 plus 4 is 5. So, geez, if I could do the math. So now let's try maybe the 4 squared plus 3. So if we wanted to do 4 squared plus 3, we could just simply do the little caret, I believe. Or no, sorry, it's double star. And then, what was I doing? Gosh. Plus 3, so if I wanted to do 4 squared plus 3, 19. 4 squared is 16. 17, 18, 19. So beautiful. So let's say we wanted to do the square root of 6 squared plus 4. I'm trying to remember, do we have to import the square root? I always forget, you guys. I think I have to import the math if I'm not mistaken. So let's go ahead and do that. Oh no. Well, let's just try it. Let's see if it'll work, right? So, what did we have? I have time for a couple more. So square root 6 squared plus 4 is QRT. Oh, see, I'm bad with numbers. I'm bad at remembering stuff. So 6 squared plus 4, so 6 double star squared plus 4. Let's see if that gives us trouble. Yep, so it's going to say square root not there, so we can say from math import. Just going to say star. This is 6.324, so 6 squared is 36, plus 4 is what? 40, right? So I guess if we wanted this to be a perfect square, well, let's just keep going. It's what's in the book. So maybe even this one seems fun. So 3 plus 5 minus 2, everything raised to the 2/3 power. So yeah, let's do it. So this would be 3 plus 5. Was it minus 2? Yeah. Minus 2. Everything raised to the 2/3 power. Let's see if this works for us. So 12, let's see what that is. That's 3 plus 5 is 8. Minus 2 is 6. I'm trying to think if this is proper, though. I can't remember off the top of my head for some reason, you guys. So 6 would have been 36, right? Gosh, I'm drawing a blank. Sorry, guys. I'm going to have to actually go back and practice some of that stuff. So compare the strings and problems. So problem with problem. Let's just keep doing a couple more instead of worrying about the math theory. So is problem with a capital P equal to problem with the lower p. So what do you guys think? I think it's going to be false. And it's false because in the ASCII table, right, or whatever table it uses, it's probably the ASCII table in Python, it's going to check for the words, right? Well, lowercase p is in a different place than the uppercase p, so you should get false for this. Okay, so find the sign of 0, pi over 4, pi over 2, 3 pi over 4. Oh yeah, let's go ahead and try that one. I have time for at least a couple more, but I don't want to do too many of them. So sine math.pi, or I don't even need math.pi, right? I already, well, let me grab the import first. Okay. So let me import it. So pi over 4, right? Let's just make sure this works. Okay, beautiful. And then sine 2 times pi over 4, which is 1, so sine of 90 is 1. I guess if I'm going to do them all, I need to do a print statement. Let me go ahead and see if it works with just the comma like they did. That's pretty interesting stuff, so maybe I'm learning some cool tricks with you guys. Oh yeah, look at that. That's beautiful. What an easier way to do this. So sine 3 times pi over 4. And then finally, the last one, comma, will be sine. I believe this is a tuple, but don't hold me to it. Pi over 4. So beautiful, beautiful. Did we get only 3 numbers? No, we got 4, huh? Yeah. Okay. That's weird. This should be 0 again, huh? And I know it's in radians because the 1's doing it right? So I don't know. I'm going to have to play around with the radians and stuff more. Okay, so the U.S. Forest Service. To find the height of the tree of the tree is h is equal to the distance between an observer and the base of the tree multiplied by the tangent of the angle formula. So if the Forest Service ranger is 20 feet away from the base of a Douglas fir tree and looks up 60 3-degree angle relative straight ahead to see the top of the tree. What is the height of the Douglas fir tree? I mean, I would love to do this, but the video's already almost at 25 minutes, so I'll tell you what, in the next video I think we're just going to go ahead and practice some more of these, because there's a lot of really cool problems here I want to work out. So, you know, the next video will come up Sunday, should be posted in the morning. My little doggy got sick today, so I had to take care of that. But we'll pick up on this forest problem. I think that's a good place to start. So I hope you guys are enjoying the Python videos, and I will catch you in the next one. You guys have a great day.